The molecule shape simulation is an interactive educational tool designed to help students explore and understand the principles of molecular geometry and the valence shell electron pair repulsion (VSEPR) theory. By providing a hands-on approach to building molecular models and comparing their shapes and bond angles to those predicted by VSEPR theory, the simulation offers a comprehensive learning experience that covers fundamental concepts in chemistry. The simulation allows students to add single, double, or triple bonded atoms or lone pairs of electrons to a central atom, providing insights into the three-dimensional structure of molecules. Molecular geometry refers to the three-dimensional arrangement of atoms in a molecule. The molecule shape simulation begins by introducing the concept of molecular geometry, explaining how the shape of a molecule is determined. The simulation provides an interactive platform where students can actively engage with the concept of molecular geometry. By building molecular models and adjusting the number and type of bonds and lone pairs, students can observe how these changes affect the shape and bond angles of the molecule. This hands-on approach helps students gain a deeper understanding of the principles governing molecular geometry. The molecule shape simulation allows students to build molecular models by adding single, double, or triple bonded atoms to a central atom. By selecting different types of bonds, students can create a variety of molecular structures and observe how the type of bond affects the geometry of the molecule. This interactive feature helps students understand the relationship between bond type and molecular shape. Students can also add lone pairs of electrons to the central atom. Lone pairs are electron pairs that are not involved in bonding, but still influence the geometry of the molecule. By adding lone pairs, students can observe how these non-bonding electrons affect the shape and bond angles of the molecule. This feature helps students understand the role of lone pairs in determining molecular geometry. The simulation allows students to explore the principles of valence shell electron pair repulsion theory, which predicts the geometry of molecules based on the repulsion between electron pairs in the valence shell of the central atom. According to VSEPR theory, electron pairs arrange themselves around the central atom in a way that minimizes repulsion, leading to specific molecular shapes and bond angles. Students can compare the shape and bond angles of real molecules to the values predicted using VSEPR theory. By building molecular models and observing their three-dimensional structures, students can see how the arrangement of electron pairs around the central atom determines the geometry of the molecule. This comparison helps students understand the accuracy and limitations of VSEPR theory in predicting molecular shapes. The molecule shape simulation provides a three-dimensional representation of the molecular models, allowing students to visualize the geometry of the molecules in real time. By rotating and zooming in on the molecular models, students can observe the spatial arrangement of the atoms and the bond angles from different perspectives. This visual representation helps students grasp the complex concepts of molecular geometry more easily. Students can also observe the bond angles and shapes of the molecules they build. The simulation provides measurements of the bond angles, allowing students to compare the observed angles to the values predicted by VSEPR theory. By observing the bond angles and shapes, students can gain insights into the relationship between electron pair repulsion and molecular geometry. The simulation provides an interactive platform where students can actively engage with the concepts of molecular geometry and VSEPR theory. By building molecular models and adjusting the number and type of bonds and lone pairs, students can gain a deeper understanding of the principles governing molecular geometry. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the three-dimensional structure of molecules, the arrangement of electron pairs, and the bond angles in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The molecule shape simulation is a valuable tool for teaching and learning about the principles of molecular geometry and VSEPR theory. By providing an interactive, visual, and comprehensive platform, it helps students understand how to build molecular models, explore the relationship between bond type and molecular shape, and compare real molecules to VSEPR predictions. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in chemistry. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of molecular geometry and its applications in various scientific and engineering fields.